Hey, Wafi, why are you staring like that? Is the football field offer you something?
No, no, no. But serious question. All of them are wearing sports shoes.
Oh, I don't sure. Wait, let me count. One, two, three. Hey! Stop lah! What I see all wearing sports shoes. No sandal, no slippers.
Good. That's we call universal quantifier.
Oh yes, upside down A eating shirt, right?
Yes, but the name is still universal quantifier and the symbol is like this. Eh, upside. Like this.
Okay. So this statement is for all people inside the box, they wear a sport shoes.
Yes, exactly. And the math equation will be like this.
But what if someone wear slippers?
No. The statement will be false.
Oh. That's mean one people rules everything.
Yes, not all, not almost all, not almost all, not most of them. No, only all.
Is for all means all.
Yes, only all. I think we can go to another place for reach out some example to know about universal quantifier more.
Let's go.
Okay.
So Richard, what do you want to eat this afternoon?
I think I'm gonna eat ayam gepuk at PP first.
Wait. I just remember something. Why don't we go to the motorcycle parking lot? I think we can discover something at there.
I think that's a good idea. Let's go.
Let's go. Where is all the motorcycle? Why is this motorcycle parking lot is empty?
Empty? I didn't think this park is empty. There is one motorcycle there.
Hey, I
You see
didn't
it?
see it. So, what does that mean in mathematics terms? Well, I'm a mathematics student.
In mathematics terms, we call it as existential quantifier, which is the symbol is E, but we inverted it. For the existential quantifier, the keyword that we use is there is or there is at least one. That's the example for the keyword for this quantifier.
So, in other words, existential quantifiers mean if there's only one thing at that place isn't empty. Am I right?
Yes, but not there is one, at least one, or at least one variable in that particular way. For example, we use X as a subject, and our subject is motorcycle park at the parking. So means for when we want to use the existential quantifier, there is at least one motorcycle at there. Then we can use that existential quantifier.
I get what you mean. Sir. I want to tell you something. Did you know that if you park here, in existential quantifier means this parking lot isn't empty?
What do you mean?
Yeah.
Huh?
Guys, listen to this statement. Why do I feel like this is about logic again? Okay, for everyone in this group, there will exist for one dislikeful.
Oh, it sounds true.
For every person means everyone here.
Yes, no one escaped.
For exist at least one food means each person
at least one food they don't like it?
Yes. For me, I don't like durian. I don't like starfruit.
I think I don't like noodle.
Everyone have a different taste, right? Different food. But the statement is still true. But what if I say everyone have a same dislike food?
Not everyone hate the same thing, right?
So we can say simply as everyone have their own dislike food.
And that we will call this as universal plus existential quantifier.
So we can combine the two.
Yes.
Everyone, today I will explain several statements that involve the quantifier, which is existential quantifier, and also universal quantifier. For each statement, I will determine whether is it true or false, and based on the answer, we will give the example or the counter example. So now let's move on to our question. Okay, now we will go to the first question. As you can see in this, so for this question, the domain is, or maybe I can say that the universal set is equals to all is integer. So it can be 0, it can be positive integer, and also it can be negative positive integer, but no fraction or decimal. So we will move on to the first problem, which is there is this x, there is this y, in bracket x plus y square is equal to 4. So this statement means there exists integer x and y such that x plus y square equals to 4. So now let's substitute x with 0 and y with 2. And we substitute these both number in that equation. Then as you can see, since we found that valid integer that satisfy this equation, means this statement is true. Alright, so for the Roman 2, which is there is this x, there is this y, and in that bracket we see that there is two statement, or maybe I would say that there is two equation, and at the same time there is symbol n in the middle of both two equation, which is the first equation is x plus y is equal to 3 and x minus y is equals to 0. So now from x minus y equals to 0, we get x equals to y. We substitute x plus y is equals to 3, and then we will get 2x equals to 3, and we let the x be alone, and we will get the x is equals to 3 over 2. Since 3 over 2 is not integer because 3 over 2 is fraction, so this statement is false. And then we will state that the counter example is x equal to 3 over 2. And now let's move on to the Roman 3 question. There is this x, there is this y. Same like question 2 or question Roman 2, there is 2. There is 2 statement, or there is 2 equation, which is same, it have n symbol in middle. So for the first question is x plus y equals to 8 and x minus y equals to 2. And then what we will do, so first we add both question in the we add both question. So we will get in bracket x plus y close bracket plus open bracket x minus y close bracket is equals to 8 plus 2. And then we simplify it, we will get 2x equals to 10, and we let x at the left alone, and then we will get x equals to 5. Since we get x equals to 5, means this statement is true, and then the example is x equals to 5. Alright, we will move on for the next question.
Hi, I will continue what my friend left for me, which is question 2. We have a 3 part here, 3 part here, and let's go to the part 1. Okay, part 1 we can see the statement is that it is x and y such that x plus y equal to 3. And we can see here the universe set is 1, 2, and 3. Okay, let's x equal to 1. Then 1 plus y equal to 3. So y equal to 2. Such that is a value in x and y that satisfy in the equation. We see this statement will be true. Let's go to the question 2, part 2. We can see this statement is that it is x such that for all y, okay, and x plus 1 less than y. Okay, then the universe set is the positive integer. Let x equal to 1, then 1 plus 1 less than y, and 2 less than y. However, if y equal to 1, make inequality become 2 less than 1. It's a false. Therefore, the statement is false. The counter example is x equal to 1 and y equal to 1. Okay, let's go to the part 3, which is the last one. Okay, let's start it. For the statement, we can see for all x that is why such that x plus y equals to 5 and universal set is 0 to 5. Okay, let's x equals to 5. Then 5 plus y equals to 5. So y equals to 0. Every value of x is a value of y. Check satisfy a question, and that's make a statement true. Okay, let's go to the next one.
So for the last question is for all x and for all y, 4 minus x squared less than y. So let's see if we let x equal to 0 and y equal to 0. So we can get 4 minus by 0 and the answer is 4. And 4 less than 0. So the statement is false. So that counter example is x equal to 0 and y equal to 0. Next, we move to the second Roman, which is the question is there exists x, there exists y. 4 minus by x squared less than y. So let's see the statement are true or false. So firstly, we see the mathematical equation. We get 4 minus by x squared and less than y. So after we change to the more better form, we get y plus x squared more than 4. So let's see what if we let x equal to 0 and y equal to 5. So we can get 5 over 4. So the statement is true, and the example is x equal to 0 and y equal to 5. Okay, so and for the last Roman, which is the third Roman, for all x and for all x there exists y, x squared less than y. So let's see, x squared less than y and y equal to 7, x also equal to 7. But 7 squared, which is 49, less than y. So the statement is false, and the counter example is x equal to 7 and y also equal to 7.
So there are two types of quantifier,
Which is first, universal quantifier.
An existential quantifier.
And that's all from us.
Thank you.